Welcome everybody to our second research method seminar. This one is going to be on data cleaning and data management using Stata, which is a statistical package that I'll talk about a little bit more in a few minutes. So my name is Jason Burns. I am a new assistant professor here in the Department of Educational Leadership Management and Policy. I'm situated in the K-12 unit, but I've met many of you who are in the higher ed program as well through some of the courses I've taught and things like that. So that's just a little bit about who I am. So just a recap about the seminars here, just in case anyone is new and didn't go to last week. So this is something new for this semester that we've started to organize. And so it's, faculty in K-12 and higher ed are hosting a series of these seminars. In the future, we might be broadening this out a little bit to bring in additional people, which would be great. The seminars are all going to be, about an hour in length. You've probably been getting the emails, like we give you a heads up about, there was a schedule that went out a couple weeks ago. And then at the beginning of each week, we're sending out something with a little bit more information on that particular topic. And these are oriented towards the kinds of skills, methods, techniques, things like that that students are going to need in their dissertation. So just keep that in mind, even if you're not at the dissertation stage now. Once you get there, there will be a repository of these kinds of materials for you to refer back to. So I've already sort of introduced myself. In case you didn't see me on the Teams, this is what I look like, and my affiliation here at Seton Hall. Here's a little bit of an agenda of what we're going to go over. So I'm going to start off by just talking about what I mean when I say data cleaning and data management. I'm going to talk about Stata versus SPSS because Stata is something new to the department. Then a little bit about just kind of general working with data in Stata. And then the techniques and the process of manipulating data to get it ready for analysis. And so that's things like transforming and recoding variables, creating new variables, deduplicating data, and then merging and appending data. So I'll go into more detail about what all of these really are as we go along here. So just a little bit about some of the terminology that I'll use. Sometimes us quantitative folks, like we have sort of conventions, but sometimes we don't all use the exact same terms. So this is just a little bit about the way that I talk about these things. So when I talk about data in quantitative data anyway, so generally what we're talking about is something that looks like a spreadsheet. Oftentimes it might be natively opened in something like Microsoft Excel or something, but you can import those into statistical software packages for more sophisticated analysis. You can do some things in products like Excel. It gets kind of clunky and there are some issues, and so using something like Stata in this case is more efficient. And so when we're talking about the contents of data, there are observations or cases, sometimes you'll hear those called. Those are basically rows in the spreadsheet. And those rows can represent one unit, and it's important that all the data in a data set, all the observations represent the same unit, meaning that your spreadsheet is all schools, it's all teachers, it's all students, it's all households, it's all colleges or universities, something like that. Because if you had a data set where one row was a student and a second row was a household and a third row was their school, it's hard to really work with that because every line means something very different. So those are observations. Then variables, so in terms thinking back to quantitative data looking like a spreadsheet, variables are basically just columns in the data set. And those columns, as you move up and down a column, it represents the same thing, even though the contents of a particular cell in a column might be different. So what that means is that as you move up and down a column or variable in a spreadsheet or data set, that same column should have something like everybody's names, should have everyone's test score or something like that. It just needs to be consistent. So in the same way that the observation needs to be consistent and that the same row represents the same kind of unit, variables need to be consistent within that column. Then there are, going a little bit kind of bigger picture. So there are sort of two kinds of data that we might work with. So the first is cross-sectional data. Generally in the methods courses that we teach and things like that, cross-sectional data is primarily what we work with. One way to think of this is cross-sectional data is a snapshot. So it's a snapshot from a single point in time. And in this data set, each unit should only have one observation. So for instance, if you have a data set that is student level, then each student should only appear in that data one time in cross-sectional data. So that means you've got data from one school year, and so each student should only be in there one time. That's not always the case when you get it, which is one thing that we have to work with. The other kind of data is panel data. And so that is a data set that contains multiple snapshots or contains multiple periods of time. And so a single unit, like a single person, a single student, will appear multiple times in the data set. So you might have one row for every student year in the data set, or every college or institution year in the data set. And this distinction is important because the way that you have to work with cross-sectional versus panel data is slightly different. And there are reasons for that that are going to be covered more in one of the more like advanced seminars. But what I'm going to show you now is primarily about working with cross-sectional data. So on to like, what is data cleaning and management? So one thing that's really great about the, sort of this day and age is there's a lot of data out there that's ready to use. The federal government collects an awful lot of data on K-12 schools, on higher education, on just the general population. There's the state of New Jersey, most states do. They collect all kinds of data on schools, their own colleges and universities, and a lot of this is publicly available. And so there's a lot of data that's out there for use, which is great. But if you have gone out and retrieved it, you've probably run into issues where the way that you, when you get that data, like it's all exciting because you're like, oh, look, I just got this spreadsheet that's got 4,000 people in it. I don't have to go do a survey. This data collection's already done for me. And you go to open it up and all of a sudden it's like, well, this doesn't make a lot of sense. And there's just a lot of stuff that looks kind of cluttered in the data set. This is pretty common. And that's because the purpose for which a certain data set is created might be slightly different than the purpose for which you would like to use it. And so you just have to do some work on it. And so the process of taking the data from the state in which you retrieve it or download it and getting it to the state in which you can actually run analyses on it is data cleaning and data management. And so that's just the process of manipulating things so that whenever you're ready, so that you're ready to go and run the analyses that you want to do. This step is really important for a few reasons. One, it's time consuming, or it can be very time consuming. Upwards of 2/3 of a quantitative study might be spent doing data cleaning, just getting the data ready to run your analyses and just getting to know it. That's not uncommon. I would say you spend less time, the more proficient you get with data cleaning and management. But I would say you're probably expecting to spend between 1/3 and half of your time working on a study doing data cleaning and management as opposed to running analyses. And so that's just in terms of an expectation. It feels like you want to kind of skip this step, but the reality is that this needs to be done to do rigorous work. The other reason why data cleaning and management is really important is because it's really easy to make mistakes at this stage that don't get caught later on. And what that means is that then you can end up with all kinds of errors. You can end up with all kinds of issues in your results that you may or may not know about. And when I say it's easy to make mistakes, there have been some really high-profile examples of this. This was several years ago. There was a collaboration between NASA and the European Space Agency to build a Mars lander, and the one agency did everything in meters, and then another agency did everything in feet, and no one realized that when they programmed the lander, and it crashed and cost $120 million or something like that. Just gone because it blew up. More recently, so like if we've been watching the news, things like student loan debt has been something that's been getting a lot of attention. And for a while, there was a statistic that was floating around about how a very large share of the total student loan debt owed is carried by very high earning individuals. And so that was getting thrown around a lot as sort of a like, well, this is kind of what you'd expect. People take on more debt, but then they get higher paying jobs. So it all kind of works out. It turns out, though, the data that was used to make that claim, there was a small error, one line of code that caused the resulting data to look much more skewed that way than the reality. And when in reality, that burden is a little bit more spread out than that. So if you want to look that up, you could look, if you wanted to Google like I think it was Urban Institute, student loan debt error or something like that. But that's just to point out like that these things happen. And so back to so moving on to the kind of processes that you do as part of data cleaning and data management that could involve things like recoding a variable, transforming a variable, mean that you're taking the values of a variable and giving it new values or creating a new variable, potentially using information from an existing variable or just creating something wholesale that's new. Data cleaning can involve things like adding new variables from another data set. We call that merging. So we want to bring in more columns from another data set. Data management can also be adding observations from another data set. So that would be called appending. So when you're adding variables, we call that merging. When you're adding observations or rows, we call that appending. And so before I get more into the process of how we do all of this in Stata, so some of the questions in the RSVP were about this question of like, well, how is Stata different from SPSS? So I wanted to address that because that's totally sensible because Stata is going to be new for a lot of folks. So a little bit of background. So the department is switching over to Stata for our quantitative methods courses. So starting really this semester, I think all of our all of our methods courses are taught using Stata as opposed to SPSS like they had in the past. And there are some reasons for this. So Stata, just like SPSS, Stata it's a statistical software package that lets you do an awful lot with data. In terms of what it means for students, Stata is free to you, just like SPSS has been. You just go through the same process, and once a year you'll need to request a license, and then you'll get that from the university, and then you have Stata ready to go. SPS, the university, to my knowledge at least anyway, the university's not discontinuing the SPSS license, so if you're diehard and committed to SPSS, you are able to stay with that. In terms of the look and feel and working with Stata, so Stata does have menus, just like SPSS does. One of the things that people have liked historically about SPSS is that it's very menu driven. You kind of click through to get to wherever it is that you want to go. In Stata, you can still do that, but you also can just type commands straight into the Stata interface. And that makes things more efficient. So like SPSS, if you had to run the same analysis several times over and over again, you'd have to click in to get back to that menu, change your things out, click run, change your things, click run, kind of keep doing that. In Stata, because you can just type a command in, it's as simple as changing a couple letters, and then you can run the same thing again. So with a little bit of practice, it is a lot more efficient. The other things that are nice about Stata is you can save everything that you do. And that is so that if you can't figure out how to do something, you get really stuck, you need to reach out to a professor or something like that. With Stata, it's really easy to just save what you were doing. So you can email them this is what I was trying to do and this is the error I got. And then folks like me can say, oh, okay, I see what you're doing. Here's what you need to do, as opposed to if you can't figure something out with SPSS, it can get awfully clunky to say, click this tab, go down to here and do all this other stuff, just because, it's just a little bit harder to explain. The other more practical reason why we're switching to Stata and why we like that is because those of us, so the faculty within the department, we're just better at Stata than we're all Stata users. And so we know that more. And so we can give you more support with Stata than we can with SPSS. So this is just sort of background as about, sort of what Stata is and why we're switching to it. There are some really nice resources in this. So this PowerPoint is going to be made available later on. So you'll be able to find these. Stata has some, they call them cheat sheets, which is basically just these kind of well laid out PDFs of how to do a bunch of different kinds of things, different kinds of commands and options and all kinds of stuff like that. They're free. There are also a couple of repositories of places that have sort of built a library that are really helpful for using Stata commands. One of them is at UCLA, another one is at the University of Wisconsin. He said they're both very good. I wouldn't say that one is necessarily better than the other, but you may find those helpful. And then also, I've started a YouTube channel of instructional videos on how to use Stata. I just started that this semester, so there's not a ton of content. I think I've got about 10 or 12 videos up there now about Stata basics, but that library of videos is going to be growing as time goes on. It looks like someone has a question.
Yes, Dr. Burns, Dr. Gutmer. So am I correct that those students, though, who were trained in SPSS can continue to use it and don't necessarily have to relearn Stata?
That's correct. Like, we're not forcing anyone to say, like, forget everything you learned about SPSS, you must learn this now. But if you want to do something, say, more advanced, like if a student comes to me and they're like, I want to do something with fixed effects in SPSS, my response is going to be, I don't know how to do that. I know how to do it in Stata, though. So that would be the kinds of things, when you might have to work something out, but no one is required to switch to Stata and SPSS. The results you get are going to be the same. That's a good question.
Thank you.
And so this is, kind of now starting to talk about like what we can do in Stata. So again, a lot of it is kind of the same. But here is something that this is one of my big selling points with Stata is you can automate a lot of tasks in Stata and potentially save yourself like hours and hours and hours. One way to think of it is anytime that you think of like, am I going to have to sit down and do the same thing over and over and over again? There's a way that if that kind of thought occurs to you, then there's a way to automate that and have Stata just do it all for you. And you don't have to be there while it's running. So like there was a data set that I was prepping for a class that I let it run. It took like 9 hours to run, but I clicked run, I went to bed, I woke up, my data was ready to go. So like those are the kinds of things that can make it really nice. Just some things to keep in mind with Stata is there's, every software package has some unique things in Stata. Some of these unique things are that just always remember that variable names cannot begin with a number and cannot include spaces. So just keep that in mind in case you're ever trying to make anything. You'll always get an error if you try to give a variable name a number at the beginning, or if you ever have to use try to put a space in a variable. So just keep that in mind. So in terms of what Stata recognizes when you bring data into it, so there's two basic variable formats. And so those are called numeric, which means numbers, and string, which means text. And so you want data to be, we would say, encoded or to be formatted as numeric so that you can compute statistics with it. You can look at averages, you can run regressions, you can do all kinds of stuff with numeric data. String variables, which are recognized as text, they can't be used to compute statistics. You can look at the contents of a string variable, but you can't compute anything with it. Having said that, just because something is all numbers, it can still be encoded as a string variable, but you can go back and forth between them. And in some of the examples that you'll see here, anytime you're working with a string variable or you're referring to the contents of a string variable, you need to that needs to be surrounded with quotes. If you're working with a numeric variable, you don't need quotes. And so that's just, if you're looking at the code that I'm going to show you, sometimes you'll see quotes and sometimes not. That would be the reason why. And so this is important to understand, but when you import data into Stata, it recognizes variables as either numeric or string based on their contents. So if you have a data set that has, like, say, a person's name and then it's got their age, as long as that age variable contains only numbers, Stata will automatically recognize that as a numeric variable. And again, we can move back and forth between string and numeric. So those are the different kinds of data. When you look at Stata, this is, if you like open the data browser is what it's called, this is what it looks like. So like I mentioned before, this is, it looks an awful lot like Excel or something like that. It's a spreadsheet. And in this case, the data is school level. So this is data from New Jersey from the 2017-18 school year. And so this is school level. So every row represents a different school. And you can see that if you look down the school name variable. So this is the name of each school, and you can see the school ID number and the district ID number and the district name and all that stuff. But you'll see that there's different colors. And the reason for that, and this makes it kind of handy when you're working with Stata, is numeric variables, the contents always show up as black. And string variables, the contents always show up as red. So if you don't want to actually like kind of, dig through some of the menus and stuff, you just go to the data browser like this, and then you can really easily and quickly see what is encoded as a string and what is encoded as a number. And so we see things like, in this case, the county name where the particular school is located, the district name, and the school name are all strings because these are obviously text. For the grade span, this is also recognized as text or a string variable, and that's for a couple reasons. One is because we see letters here, but also the numbers, or sorry, not the numbers, the dashes. So because all of this is considered to be text, so the actual letters, but the dash also makes it a text. So that's why that's recognized as a string. This is the sort of the basic format for what Stata code looks like. So what I'm doing here is this seminar is kind of divided up into two sections. I'm going to kind of review like, this is what the different kinds of data management tasks. Here are the commands that there are, and then at the end I'll actually show how this works in Stata. The way to learn Stata is, it's hard. I mean, in an hour you're not going to sit down and watch this and become a master of how to do everything in Stata, as nice as that would be. It requires a little bit of time just kind of getting into it and playing around with it. So the stuff that I'm going to use in the second part, where I actually show you how to run stuff in Stata, that's all going to be made available to you so that you can open it up and you can play with that, run it, and kind of just get used to putting those commands into Stata to see how it goes. So, but before I get more into the actual data manipulation tasks, this is like I said, the basic format for a Stata command. And I color coded it just for visual appearances. You don't actually have to color code anything when you're working in Stata. So the first line is just the command. And so that can be things like to creating a variable, to run a regression, to get descriptive statistics, so all of that. So there's a command. So that's telling Stata what to do. Then you'll put one or more variables. And so that is, you're telling Stata to perform a command on these variables. And so basically every time you work in Stata, you're going to have a command and then variables. This part here, like the conditional, so this is not necessary. So every time that you do something in Stata, you're not always going to have a conditional statement. But what that does is it tells Stata to just perform that command only on certain observations. So like, say if I wanted to go back here and let's say I wanted to do something, but only for the schools in Atlantic County. I would just use a conditional statement and I don't have to do anything else. I just tell Stata to do this command, but only for the schools in Atlantic County, and then that's what it'll do. So that's what a conditional statement is for. And then the options, so there will be a comma, and then there's options. Options vary quite a bit across different kinds of commands, but that's just about giving Stata more specific instructions. And if you're ever trying to figure out like, okay, what do I need to do? How do I put this code together? Help is your friend. So if you're in Stata, you just type help, then whatever the command is that you're trying to use, and then you're going to get a help menu that kind of shows how to navigate that. And sort of on that note, eventually from working with Stata, you can sit down and you can just kind of type and code everything up. But especially starting off, a good bit of your time is you might remember, okay, this is the command that I need to use because this is what I want to do, but I forget exactly how to put that command together. And so it's pretty common, especially as you're learning, to spend some time like, with the help menus to kind of figure all of that out or kind of refresh your memory. So first off, one kind of data management task is, would you say, transforming or recoding a variable. I tend to use these two things interchangeably, so that's why I'll say like transforming and recoding. I mean, like I said, I use them interchangeably. So what that means is, so I'll say one way to doing that, is to we call it destringing. So that's where you take a variable that is a string in a string format and converting it to numeric, because you want to use it to run analyses of some sort. So to do that, all of the values of a variable have to contain only numbers. And so as long as that's the case, then you just type in this command that says dstring, the name of the variable, and then you just use the replace option. And then it will just take that same variable, convert everything from string into a numeric, and then you can just go run all kinds of analyses on it. So that's the simple version of destringing. However, let's say that you run into a situation, because this happens, where there is one value of that variable that has something, I'll say weird, meaning like it's a test score. The variable is something about test scores, but then there's an N somewhere in there. So this happens because, like, for school level data, sometimes if it's a very small school, they don't report that because of, they call it sample size concerns. And so that data will just say N instead of a number. So what you want to do is you want to get rid of that N so that you can, that letter N, so that you can replace it, or sorry, so that you can destring that variable. So what you need to do is just, you're going to replace the value of a variable with another value. So you can do this for any reason that you want, but like I said, what I end up doing this mostly for is to get ready to destring a variable. So the code would be, and so this is again to replace a value of a variable. So this would be replace, and then there's the name of whatever variable that you want to do. To be, and the first set of quotes there says new value. That's whatever you want that the new value of this variable to be. And then you'll see here that there's a conditional statement. So like, if that variable equals some specific old value. And so it's hard to, I know this seems kind of abstract. I'll show actually like how to do this, towards the end after I go through the slides and show like this is how it all works in Stata. And so what this command here will do is it will replace the specific value of a string variable with a different value for all observations that meet the condition. So like I said, this sounds abstract. I'll go through this again when I actually show this code running on Stata and to show what it does. Renaming is actually much easier. So when you're doing something like recoding a variable, that tends to be I think it tends to be a little bit trickier, or at least I run into more errors when I'm trying to do that. And when you're trying to rename a variable, that's really easy. Sometimes you want to rename a variable just because you want to make it's a very long name and you want to make it a short name. Sometimes you need to, especially for when you're merging or appending data, you need to have all the exact same variable names. So that's when you would rename a variable, and it's really easy. The command is rename. Then you type the old name of the variable, how it is in your data set, and whatever the new name that you want it to have is. And that's it. And then it will replace the name of that variable with the new one. Creating new variables is also pretty straightforward. It's pretty easy. And so you can create new variables in a lot of different ways. So one thing you could do is you could create a new variable with a specific value. Which means like you want every observation in the data set to have a certain value. So like, let's say the data set that I showed a little bit ago, that was all the schools in New Jersey, there's not a variable in there that says New Jersey. We just know that because I got that data set from the New Jersey Department of Education. But if you wanted to, you could type in the command that says generate state equals New Jersey in quotes, because that's text, and it would create a variable called state, and every observation would say New Jersey for that state variable. So that's how you would give every observation the same value. You can also create new variables using data that's already there. So if you've done much in Excel, like with formulas and stuff like that, basically any formula that you might use in Excel, you can do that when you're generating a new variable here in Stata. So let's say you have a variable that shows the enrollment in a school, and you have another variable that shows teacher FTE, so that would be full-time equivalent teacher positions. And let's say that you want to get what is a student-teacher ratio, but that data is not in the data set. So what you can do is you can just create a new variable. So generate ST ratio, so that would be our new variable name, and that's equal to the enrollment variable divided by the teacher variable. And so that new variable, ST ratio, will give you the student-teacher ratio, because that's the formula that we're using here. You can add across a bunch of different variables. You can divide, you can multiply. There's, whatever formula you want to use, you can do that with the generate variable. One thing to just keep in mind is make sure just use parentheses to make sure that it does the order of operations correctly. So just keep that in mind. I think using Stata is a good example of how sometimes people say like, oh, computers are so smart. And like, computers aren't really smart. They're really good at following directions is what they do. And so keep in mind that you want to be really specific about the directions you're giving the computer to do. And so that's why I say, like, I like using parentheses if you're going to use formulas and stuff like that with the generate command, because otherwise it's really easy to wind up with something that doesn't make any sense. Another thing, sort of practical tip here. So whenever you're doing something to transform a variable, to recode a variable, create a new variable, anything like that, always check to make sure that the software did what you wanted it to do. And depending on what you're doing, that means go into the data browser and actually like look at the data in spreadsheet form and make sure that what you're seeing makes sense. Or depending on what you're doing, sometimes it makes more sense to just use some descriptive statistics or something like that to just check and make sure, like, oh, okay, like this is what I want it to look like, and that's what it looks like. And so you might say in your head, just like, okay, so for this observation, the student-teacher ratio should be this. And then you can look at the student-teacher ratio variable and say, okay, yep, that matches up, that's right. So it did what I wanted it to do. Not everyone does that, but that's a me thing, because I've seen a lot of mistakes, and like these kinds of really simple steps would have caught a lot of it. So just kind of go slow and always check your work. So another thing that you might have to do is what we call deduplicating the data. So this goes back to, there are different kinds of data, cross-sectional data and panel data. And so especially when you're working with cross-sectional data, each unit should only be in your data set one time. So let's say that you have a survey. You've administered a survey, and so you've got a spreadsheet that you pulled from Qualtrics or something like that. You only want a respondent or a person to be in your data set one time. But especially in surveys, what can happen is people respond to the survey multiple times, or because of the way software like Qualtrics works, they start taking the survey on their phone, and so that gets recorded as a response, but then they go do the survey on their computer, and then that gets recorded as a separate response. And so that's how you get these duplicates. So the same person is in your survey twice because of that, or for who knows, random reasons, people wind up in your data set multiple times. I think if you're in K-12, attendance is the big cause of this. When I say cause, what I mean is students who transfer between schools, they'll show up in school A, and then because they attended that school for a certain period of time, and then they attended school B for a different period of time, and so they wind up in your data set twice. So they wind up in the data for each school one time, but if you look at something like, say, across the district, then you're going to have that student in there two times. And that's a problem because if you have duplicated observations, that's a source of error. It counts twice, which can throw off averages and things like that. And so that's why you don't want duplicates. Like I said, it just happens. You always want to check, but sometimes it just happens. Whenever you find duplicates, what you want to do is you want to remove duplicates and just keep the right observation for each person or unit or whatever that's in the data set. So here is how you would do that. First off, you want to find all the observations that are duplicated. So what this code down here at the bottom does, creates a new variable called duplicates. And that variable says how many times the value of the variable is duplicated. You can also have multiple variables here. So like, let's say that you had, say, first name and last name in a data set. Well, if you just looked at duplicates by last name, you're going to see repeats most likely. If you look at duplicates by first name, you're going to see lots of Tommies and lots of, Billy's or Jenny's or whatever. But that doesn't mean that every time a student is named Jenny, that's the same student, right? Because think of like first and last name combinations, right? So you can use, when you're looking at duplicates, you can use first name and last name. And so what the code would then do is it would just look for instances where first name and last name are the same in 2 rows. On that note, so you can use names for stuff like this. Don't use "this is me." So take it or leave my advice. Stata will work if you're trying to deduplicate or look at duplicates with names, which are string variables. But I always have a lot more headache trying to use names and string variables than working with like an ID number. And the reason for that is, let's say that you have, let's say that there are duplicates, and you're looking at names, diminutives. So like, a person might be recorded as Tommy in one line and Thomas in the other line, even though it's the same student ID number, say. They could be recorded in there twice, or sometimes people will actually go by their middle name and not their first name. So, one record was populated from their like official registration, which is going to use the name on their birth certificate, and then another line is going to have the name that they actually go by in classrooms or something like that. And so then you have a duplicate there that you wouldn't catch if you're just using names or string variables. But basically what you do is, after determining which variables are you would say your ID variables, which variables identify a unit, variable or variables identify a specific unit in your data, you use that to generate this variable I call duplicates. And then if you just type in table duplicates, it's going to give you a table and show how many times there are duplicated observations. If that little table, when you type table duplicates, if there's a row greater than 0, that means you've got duplicates somewhere. And I'll show you ways to actually get in and figure out where they are and kind of what to do about it. So the way I'm going to show you to kind of go about all of this is I would say the most conservative way. It takes a little bit more time, but it also is less likely to wind up with error. So that's just like, if you end up looking up some of this on your own, you'll see different ways of accomplishing some of these things. Some of them will take less time, but might be more error prone. So that's just a thing that if you happen to be looking elsewhere. So let's say that you have duplicates, and what you need to do is you got to drop some of them so that you only have one copy of each unit. So let's say we're talking about people. That's, I think, easiest. So let's say that I'm in the data set 3 times. Well, I only want to be in the data set once, so I'm going to figure out which 2 observations to drop. If the values of all the variables are the same, then it doesn't matter, right? So if somehow I just got all of my data got copied 3 times into the data, then it doesn't matter. I just keep one of them and kind of move on. Then it doesn't matter. However, if the values of variables across duplicates is different, then you got to figure out, well, which version do you want to keep? So this is the case, especially with, say, survey data, right? So someone, like in the example before, say I start a survey on my phone, I complete it part way, and then I go and I take the survey on my computer and complete it. But you look at that, and you say like, oh, I didn't respond exactly the same in both of those pieces of data. So then you have to figure out, well, which one do you drop? And so there, I don't have a hard and fast rule to say this is how you do it. You just need, you as the analyst, as the researcher, just need to figure out what the rules are. But if you want to look at like, okay, what is different across these duplicates, you would just type in this code here, sort whatever your identification variables are. So that would be whatever variables you use to identify duplicates, you just type sort, then those variables, and then you just type browse if duplicates is greater than 0. And what that's going to do is it's going to show you the spreadsheet version of the data, but it's only going to show duplicates, and it's going to put all of your duplicates right next to one another in rows. So you'll be able to see, oh, okay, like this is the same or this is different or something like that. And again, I'll show how this works in a little bit. So when it comes time to, aside from after you've determined like, well, okay, why are there duplicates? and you need to actually remove duplicates. So you need to, get down to where you only have one copy or one instance of a unit in your data. You can manually delete them through something called the data editor. If you have a very small number of duplicates, that'll work. But if you have hundreds of duplicates, that takes a lot of time. If you look through your data and you determine that all of the data are exactly the same, there are just randomly multiple copies of the same things in there, the same elements in there, then you can just randomly drop duplicates. And so the code that I have here, where it says duplicate drop, whatever your ID variables are, and then that force option just tells it to pick one observation at random and get rid of the rest. Be careful about doing that, because if there are differences, then now you don't know which version you've kept and which version you deleted. But if you feel really confident that everything is exactly the same, then this force option is good because it's efficient. Like, it just does it all for you. Another way to do it is, what you can do is come up with a set of rules for which observations you want to keep. And this is going to vary depending on your task, your study, the data you've got, things like that. But what you can do is start off by just create a variable called keep, just create a new variable, and then use your rules to say, like, keep if, so let's say it's a survey and you decide, well, I just want to keep the most recent response. So what you can do is you can say keep if, and then whatever variable has the timestamp on it. So you can say, keep if, you can change that variable keep to be a 1 if it's the most recent survey response. Or let's say that you have one variable, let's say that you have some observations and the variables are all the same, except one variable is missing in one observation and one variable is not missing in another observation. So you would just say keep if this observation is not missing, or something like that. So what you would do is you would just kind of like apply your rules and keep adding more and more variables to be a keep is 1. Then after you've applied all of your rules, then you just type in this command, keep if keep equals 1, and then it's going to drop all of those duplicates that you don't want. If you're doing this is another instance where you really want to keep looking and make sure that it's coding everything, that the data are turning out how you want. And if you're thinking like, oh, this sounds kind of complicated, and that is because doing deduplication like this with a bunch of rules can get really complicated. So just kind of keep that in mind. This is especially relevant if you are doing data collection. If you're downloading data from, say, the State Department of Education or from one of the federal repositories, you tend not to run into random duplications like this. But if you're doing original data collection, it's really easy to collect your data in such a way that you wind up with duplicates. And so just keep in mind that if you're not, if you're a little bit, I don't know if I'd say careless, but if you're a little bit kind of like freewheeling or whatever you want to say, you can wind up, that can wind up leading to duplicates that are going to cause you a pain down the road. So like I said, if you're doing original data collection, tends to be where you run into more of this third type of deduplication. So the last two kind of tasks here for data management that I'm going to go over are merging, which is when you want to add variables. So this is for a case where you have different information, different variables about the same units, but they're in different files, they're in different data sets. And what you want to do is you want to put those data sets together. So, this is, say you've got one data set, and I'll say like for K-12, so you've got one data set on the characteristics of students, and you've got another data set that's on like their test scores or some achievement measure. You want to be able to put that together. Merging is how you would do that. And so you can think of what merging basically is let's say that you sat down and you wanted to add variables from one data set to another, and you sat down like, okay, where is Susie in this data set? Okay, now where is Susie in this data set? Okay, copy this other data about Susie and paste it into this other line where Susie is. You can imagine like doing that by hand is very, very, very time consuming. So don't do that. You just use the merge command, and it does all of that for you in the span of a fraction of a second most of the time. Stata does all that for you in a fraction of a second. But to do that, so you can save a lot of time, but to be able to merge data, you need a few things. So you need one or more variables of the exact same name in both data sets that identifies your observations. So that would be something like a student ID number, a school ID number, something like that, something that links them together across both data sets. The values of those identifying variables have to be the same and in the same format. So if that's one reason why numbers tend to be really good, is because numbers basically look the same no matter what. But sometimes you'll see a school ID number encoded as a string that says 0110, but in another data set, that same school will just show up as 110 without the 0 in front of it. So if you had, that would cause a problem because it's not exactly the same. So that's why it's important to, you have to do a bunch of checking before you merge to make sure that everything is the same. So anyway, so aside from, you need to know the name of the variables that identify your observations. The names and values of those identifying variables need to be the same and in the same format in both data sets. What that means is if it's a string variable in one data set, it needs to be a string variable in the other. If it's numeric in one data set, it needs to be numeric in the other. And the last thing is you need to know the file path. So that is, where does your data live? Like if you're, so that would be, if you're a Windows user, it will say like, C:/user/documents/ a bunch of other stuff going through folders to eventually where your data lives. So that's a file path. So you just need to know what that is, and it's really easy to find it. I'll show you how to do that. So the process of merging data basically goes like this. First, you load into Stata one of the data sets that you want to put together, and in Stata terminology, that's called the master data. Then you need to figure out, okay, well, what are the identifying variables that link observations in one data set to observations in the other data set? So you need to make sure that you know those. And then the last thing is, so there's 3 different ways of merging data, and I'll show you why that is and how that works. But basically, it depends on whether the identifying variable or variables are duplicated in one of your data sets. So you just need to know what kind of merge you're doing. And I have visuals to show, because I think the visuals are a much easier way of saying like this is what you're doing, as opposed to just text. And then lastly, the file path. This is where the file path comes in. For the other data set and Stata language, it's called the using data set. And so that's going to be the data set that you're going to pull variables from. So in short, the merge command tells Stata to take variables from the using data and put them onto your master data. And then you'll have an assembled data set. So these are the 3 different kinds of merges that you can do. And like I said before, it all depends whether there are duplicates of the identifying variable in either data set. So there's what we call a one-to-one merge, which is when there's no duplications in either data set. Then if you have duplications in your master data, but not in the using data, that's called a many-to-one merge. If you have no duplicates in your master data, but you do in your using data, that's called a one-to-one merge. Sorry, a one-to-many merge, I'm sorry. And if you're thinking like, well, what about a many-to-many merge? Never do a many-to-many merge. The Stata documentation literally says, never do this. Like the command will run because that's just how they had to build the program, but it says never do a many-to-many merge. And the reason for that is because it randomly matches observations in using and master data, and you really have no idea how your resulting data set's created. So here's the visual. And so this is thinking through like, what would you have to do if you had to hand do all of this? So this is a one-to-one merge. So let's say you've got on the top, these top 2 data sets. So you've got, one data set has height, one data set has weight, and we've got this variable called ID, which is nice because it's a number. And there's only one, each person only appears once, only appears once in your master data on the left and in your using data on the right. And so basically what you're doing is like, okay, you're telling Stata to say, okay, all right, Marquise weighs 140 pounds. Okay, go over to the first data and make sure, your first data set and add weight so that Marquise shows to be 61 inches tall and 140 pounds. Now go on to the next one and say, okay, Sally is 63 inches tall. How much does Sally weigh? Go to the other data set. There's Sally. She weighs 110 pounds. Put that together. And so Stata just does that really fast, and it would get you a data set that looks like the one on the bottom here. And so that's when there are no duplications in either your using or your master data. So here's a situation where we have duplicates in your master data. So on the left, at the top here, is school level data, right? So each school identification number only appears once. But because there are multiple schools in a district, there are multiple observations that have the same value of that district ID number. And that's not a problem. Like, this is what you'd expect, because this is how schools and districts work, right? Schools are nested within districts. On the right, though, we want to merge in, say, district characteristics. And so this would be something like state revenue, because it's like the money that comes from the state to the district, because money comes to the districts, not to the schools. So let's say that you want to put a district characteristic onto this school level data. So that would be a many to one merge, because district ID is the variable that you're using to match on. And there are duplicates of district, which is not a problem in this case because it's a school level data set. And so basically what you're doing is you're telling Stata with this merge many to one command is you're saying like, okay, district 112. I'll go over here, find the only case of 111. Go over here, find district 111 and copy $3.6 million over here. And so that's what it did down here. Then, okay, so district 112, go back over here, look for district 112, 14 million is what's there, copy that over to here so that school 1002 in district 112 has 67% proficiency and the district gets $14 million from the state. Oh, here's another district instance of district 112. Go back over here to the same place, copy this $14 million value over to here, which is what it's doing down here in the bottom. So this is the many to one merge. I know this kind of sounds, explaining it sounds redundant, I'm sure, because the process of doing it is redundant. But like what I'll show you in like the Stata portion is like Stata does this for about 2,500, can do this for about 2,500 schools in like 2 seconds. And so just think of like the time that you can save when you're trying to put data together, because oftentimes, you're working on a dissertation, you're like, oh, I've got this great data here and this great data here. And you need to put them together. And so merging is how you can do that without having to spend weeks like hand coding and copying. So this next verse, this is a visual of what a one-to-many merge is. And so you'll see the variables are slightly different, but the intuition is the same. It's just flipped backwards. So you've got a university level, your master data is university level, university ID, and it's got tuition. So, $24.1 thousand, $12,000, $18,000. This is all made up. So I'm saying that's what it means. But in the data, you're using data on the right. So that's student level data. So you want to put these together. And so you'll see that and if you look at the resulting data down here at the bottom, you'll see it put them together. It just, instead of saying that there's only one version, there's only one version on the right side and there's multiples on the left side. Now there's one version on the left and multiples, on the right hand side. So you can see down here it does the same thing. One thing that you might notice though is because student number 1005 here. So we have, like in this data set, they're associated with a university and they have a value for financial aid, but because our master data didn't have that university in it, university 4444, then when you look at the resulting data, that's just empty because we don't have that piece of data. So and that's what you would want. You would want this to be empty or missing, but this is just to show that's what Stata will do. If you don't have a perfect alignment or correspondence between your data sets. So here are some sort of just notes on merging data. Merging data can be frustrating the first time that you do it, because it's one of those things where if you had to sit down and do it, the steps of manually, say, merging data over are pretty intuitive, but mentally you sort of skip over a lot of it. And so that can be the source of some frustration. So that's just when you sit down, expect to run into some errors right away. And so the cause of errors are generally because the data wasn't deduplicated when it should have been, or you're using the wrong merge command, or something like that. So that tends to be the cause of errors and then frustration when you're merging data. Another thing to keep in mind is, so by default, Stata is going to merge all of the variables from your using data onto the master data. Excuse me. If there are variables of different names in both data sets, you're just going to wind up with duplicated variables, and Stata is case sensitive. And so the example that I'll show you, we're actually going to see that even though the contents are the same and the name is really the same, but because there are capital letters in one and not the other, you'll just wind up with duplicated variables. That's not a problem. That's just knowing that if you're like, why do I have two variables for the school name or something? That kind of stuff happens. It's not going to cause a problem for analysis, but when you look, you might notice that. There's an advanced option that I'm not going to show you today, but if you really want to only copy, say, two variables from your using data, there's a way to do that. You'll just need to look at you look in the options. You just type like, help merge and look for the merge options. Also, this is more of an issue. This is kind of rare, but this can happen. So let's say that you've got your master and your using data, and there are some variables that are the same. You have some of the same variables in both data sets, but the values aren't the same. So that can cause conflicts. So what you'll have to decide ahead of time is if those values are not the same, what do you want to do? Do you want to stick with all of the values in your master data? Or if there are conflicts, do you want to take all of the values from your using data and use those to overwrite the master data? This is not something that I'm going to show you how to do, but this can happen depending on your use case. So that's more of a just keep in mind that if you run into that, there are options in the merge command for how to deal with that, but that's also an instance where you might want to check with someone and figure out why do you have the same units and the same variables, but with different values. Because that means that something happened and you want to make sure why. And then the last thing to do is, like everything else, when you're creating variables or you're transforming variables, you always want to check that to make sure that Stata did what you want. Same thing when you're merging data, like look at it or run some analyses or something like that, just to make sure that the merge did what you wanted it to do. And then something I mentioned before, I'll say it again, don't merge using names if you can at all avoid it. And like I said, it's just prone to problems. So anyway, that also means that if you are, say that you have the opportunity to request data, so let's say that you work for a university or you work for a district or something like that, and you're going to be, I'm going to get this piece of data on attendance, I'm going to get this piece of data on testing, and I want to put them together. When you're doing that, always ask for an ID number. And most districts are going to have a data person, a data manager, someone who's going to run that report for you. So don't say like, I need all the students, and I need all the students and their days, the number of days that they were absent, and then I need separately, or they say, and it's a separate report I can run that's got their test scores. That's great, but just if you do that, just like please give me their student ID numbers with that data set instead of their names. Like I said, I'll speak from personal experience. I did that once when I forgot to ask that when I was working on my dissertation. And basically I was trying to merge SAT scores onto transcripts. And so I spent about 2 weeks full time doing nothing but figuring out which student in my SAT file was my student in my transcript file, because of stuff like those bubbles that they use for the names on SAT forms are only so long. And so some students with long names get their names cut off, so it doesn't merge. And so that's why I say, like, don't use names. Always ask for the ID number, because the ID number is going to be really clean to merge. Don't merge on names or strings unless you absolutely have to avoid yourself headache. Appending, on the other hand, is actually pretty easy. So appending, this is where you're adding observations. So this can happen where, say, you don't have complete data on the population that you want to study. But by putting together multiple data sets, you can put together a complete population. So this would be something like, say that you work for a school district, and let's say that you separately can get information on the students in the lower elementary school, the upper elementary school, the middle school, and the high school. Let's say you want to put all of that together into a single data set. So that would be an append. You're adding observations, you're not adding new variables, really. You're adding new rows. And so when you do that, here are some things that you got to keep in mind. Stata will automatically line up your variables and copy everything exactly how you want, as long as a few things are met. So the variables in both data sets have to be named exactly the same, that they're case sensitive, all of that. The variables have to be exactly the same. The variables also have to be in the same format, meaning string or numeric. And then the last thing is you just need to know the file path, because you're telling Stata to go to this file and stick all of those rows at the bottom of this data set. And the command is really easy, as you see here. It just says append using whatever the file path is. And then Stata is going to go in, and it's going to take all of that and put it right together for you. So here's an example of a mistake. So you have these two variables. So this is where you've got, students from one school and students from another school, and you want to put it all together. But if you look here in this first data set, there's a variable called test score, and it's got our test scores. If you look over here on the right, though, the variable that has our test scores is called assessment. And so when you append this together, Stata, because they're not exactly the same, Stata says these are not the same variable. And so what you'll get is what you see down here. So it's test score here, and then and missing for the other school, and then and then it's missing for assessment, but it's got the numbers for the other school. If this happened, you could use like the replace command that I showed you a little while ago and fix this if you wanted to, or you would just make sure that the variables have the same name. So assessment. Then when you run the append command, it's going to put everything together just how you would want it right here. Some last sort of tips here before I jump into Stata and show you, how some of this works. So when you're working with secondary data, so that means data that someone else collected, you're downloading it from a website or something like that. That's all secondary data. When you do that, always make sure to look at and preferably download a copy of the technical documentation or the code book that's used, because chances are you're going to have a question of what does this variable mean, because especially the federal data sets, I think are they do this really commonly, where the variable will be named RT7AA94N or something like that. And that means something, you just don't know what that means. So the technical documentation is going to have that. Or if you're thinking of, if it's like test score, like, well, which test? The technical documentation is going to tell you, like, well, what was that test? Or sometimes things like, thinking of absences, for instance. What is an absence? Like, conversationally, we're used to thinking like, oh, an absence means that a kid wasn't at school that day. But what you find is, like, is an absence defined as they weren't there in the morning, so they're counted absent? Does it mean that they missed the entire school day? Does it mean that they missed half the school day? There are different ways that these things are defined, and so that's where the technical documentation really comes in handy. Also, this stuff that I showed you about like data cleaning or data manipulation basics, this can be tedious. But aside from getting the data ready for analysis, it helps you to really get familiar with the data, so that when it gets to the analysis stage, it's less of like, what is this and how does this work and things like that. You've already spent a lot of time with that in the data cleaning process. Another thing is, and this is a tip that will probably make your life easier, especially if you're the kind of person who, like, you might be able to really work hard on something for a week or two, and then you have to walk away from that because of work or family or life or, whatever. Keeping a record of what you're doing is going to be really helpful. So that can be just a journal, like you're literally just writing down what did you do to your data that day. In Stata, it lets you can log, like it'll just record all the commands that you type in. Like there's a way to do that, and that can be one way to keep track of what you've done. Stata also lets you keep track of your code, and so annotating it means like you're just typing notes to yourself basically in the code for you to see later. So like all of that really helps to record what you're doing to the data. Also, because the process of cleaning data can be really tedious and time intensive, having a plan is really important. So like having an analysis plan. What analysis do you need to run? Which variables do you need to run that analysis? How do those variables need to look? Like start there and use that to guide the data cleaning process, because it could be that you could spend a lot of time trying to get variables to destring and all this other stuff, and then it turns out you don't need them. So, in theory, you could spend a couple of hours manipulating a bunch of these variables to get them all to be converted from string to numeric, but then you ultimately don't need them for your analysis. So that's why it's important to know just ahead of time, what do you need from your data, and then use that to guide what you do to it. And then lastly, like, last two things, like being thorough, like putting in the time to like try to do it right is going to pay off, because then when you go to run your regression or something like that, and you type in that code and you click enter, it's just going to run, and you're going to get the results you want, and you're going to be happy, and you can go start writing up your findings. Versus you get an error because there's a format that's weird, or you get some other kinds of weird errors, and now you have to go sort of back into the data cleaning process. And then the last thing just to keep in the back of your mind is this note here of like any repetitive task can be automated with code. And so that's not like, here's how you fix that problem. But like I said, if it occurs to you like, well, am I going to have to spend 12 hours doing the same thing over and over again? There's probably a way to have Stata do that for you. And it'll just run it all either in a couple seconds, or if it takes a while, like I said, you can let it run. Like I've had to let code run for like 12 or 14 hours because like it's just doing all of that for you over and over and over again, and you can save your brain power for something else. So what I'll do now here is if folks have to go, like please feel free that if you have to, I know we're running a little bit on the longer side, so feel free if you have to run, but I'll just show like how does this all actually work in Stata. So to start off, this is a data set. This is an Excel file that I downloaded from the New Jersey Department of Education. So this is they call it the school report card. And so it's got, if we scroll down through here, 2000 and something. Oh, hold on, that's for high schools. So there's 300 and some high schools with a graduation rate. This particular spreadsheet has 57 tabs. But let's go. So this is the main like directory information. So this is every school that was in the state of New Jersey, public schools and most charters. And in the 2017-18 school year, there's 2,500 and I think 19 of them. Yeah. And so let's say that we want to put together some of these tabs. So there's like, we want to take this basic information, and let's say we want to put it together with data on enrollment and a little bit about demographics of students. And let's say that we want to, I have to go like way down here, but there's a variable that has characteristics of administrators in the district. So let's say that we want to put all of that together. Oops, gotta find the right. And it's this tab, right? So this tab has every district as a separate line. All right, so let's say that we want to put all of that together. So what I would do first is this is an Excel file, so you would have to import all of this to Stata, and get it and turn it into the version that Stata can use. I've already done that ahead of time. If anyone wants to work with this kind of data, this is one of those like really time-consuming processes, but I can give you code that like you just let it run overnight and it just imports this tab, converts it, goes to the next tab, imports that and converts it. It just does that all for you. But anyway, so here is a do file, which is just the code that that you can code that you can run in a way to like save what you did. And this is going to be made available to everybody. It won't be tomorrow, might not be next week, but it will be on the blog is where we're going to be hosting all of this kind of stuff. So you'll be able to work with these specific files if you want to try to replicate what I'm doing here. Excuse me. So this is what's called a do file. And so this is where you write and you can save code. This window here that you're seeing is Stata. This is what it looks like. So up here, this window in the middle, this is where your output shows up. If you wanted to just type commands straight into Stata, like this is where you would type all of that. It keeps a little record of the commands that you type in over here on the left. Once you have data loaded, you're going to see a list of all the variables right here. And then if you click on a variable, you're going to see information about those variables down here. If you're a Mac user, Stata is available for Macs. It just looks different. So what I'm going to do here is I am going to just kind of split my screen. And then just give me 1 second. I've learned from teaching that this shows up very small for you guys, so I'm going to make the font maybe not that large. But hopefully this will let you see things a little bit better. So we're going to start off with, this is a file path. This is the file path on my computer where our directory data set lives. The file path on your computer would look different. If you're ever not sure, like, well, what's the file path to get to something? If you just like, so this is a Stata data set right here. I'm going to open this up and you're going to see a separate window and you'll see that says use blah, blah, blah. Or like, here's the code, like this is the file path. So you could just copy and paste this somewhere. So I'm just going to close that right now. So now we have, and if I want to go and actually look at it in spreadsheet format, here's the data browser. So this is the spreadsheet that I pulled in. So it's got every school in the state. Over here, you can see there's 2,519, and you'll see that these are all string variables, because they're all red, and that's fine. But this is kind of neat because it's got the county name, the county code, the district code and name, school code and name, grade span, the address, the email of the principal, their website, if they have a Facebook page or a Twitter handle, like this is the stuff. This is the neat kind of stuff that's just publicly available. So let's say that we want to merge in some other data from that Excel file that had 57 different tabs. So let's say we want to put some of that together. Well, one thing I know ahead of time is that I need to rename the district code and school code, because in this data set, you'll see everything is capitalized. So it's capitals, all capitals, district underscore code. If I were to look in this, go back to this data set, maybe I shouldn't have closed it. It's not all capitalized. And because of that, you can't, a merge won't work because the variable names aren't the same. So what I need to do to start off is I just need to rename these two variables. And if you were doing this for real, you might, I've already worked all this out ahead of time, so it's going to look really smooth and nice. But in the real world, you might run into a few errors along the way. So first off, what we want to do is we don't know what kind of merge we have to do. So I'm pretty sure that we have that every observation is a school, and there are no duplicate schools. There shouldn't be, right? The state shouldn't be putting out a list of schools where the same school is in there twice. But we want to check that. So let's start off with this school code variable. So I'm going to use this duplicates tag school code. And so it's generated a new variable. It's down here called school duplicates. And so let's make a table. So it's this tab school code. And now we see something really weird, because that means that there's 399 schools that have the same school code. So this looks weird, right? So let's look at that. So what we can do is, we'll type sort school code. And so what that does is it just arranges the data so that every, ordered by school code. Now I can use this browse command. And so that's going to show me all of the observations that have a duplicate school code somewhere. So now if I'm looking here, so our school code is what we're using. All right, so there's 4 schools that all have the school code of 002. That's not right. But then if you look over here, the schools all have different names. They're in different districts. And then if we look down, like, oh, it's really the same thing for school code number 3, school code number 4. Like, these are just schools in different districts. Just the school is, school districts are reusing the same school code numbers. So like, okay, now we can say, all right, well, there are duplicates by school code, but that doesn't mean that the same school is in there multiple times. So it looks like schools and districts should be unique, or there shouldn't be duplicates there. So I'm going to run this duplicates tag command again, but use school code and district code. Okay, so then I'm going to say, okay, like, well, how many times is there the same school and district code together? How many times is that combination repeated? So then I'll run this tab and it says 0. So what that means is we can feel pretty good, like, okay, so school and district code identify a particular school. So now we say, okay, so we feel pretty good about this. There are no duplicates, and so that means the kind of merge in our master data here is a 1. So because this is all unique, and I can just tell you, because I've already looked at it, that it's the same in our using data. So what we can do is go down to this this line here. So we're going to do a 1-to-1 merge. We're going to use school code and district code because there are no duplicates by those 2 variables. So then I just run that. And what this told me is that, like, in the time that spat up, it took 2,519 observations from one data set and stuck them alongside the right school in the other data set. You can think, like, imagine if you had to do this by hand and, like, copy and paste all of that, you'd probably spend, I would wager, 5 hours doing that, assuming that you don't need a bunch of breaks. And Stata just did that for us in about 0.6 of a second. So then what we need to do is, like, let's say let's keep going. So this new data that we've got took the directory information that's just about, like, the name of the school code, the address, the principal, the phone number, their website and Twitter handle and all that. And it's added on, oh, look, it's got their grade span information. It's like how many pre-K students are in that school, how many 5th grade students are in that school, how many total students are in that school. So that's pretty neat. But if you look, there are some duplicate variables. So there's this school name spelled like this. But if we go over here, there's another variable. It's also school name, but it's not exactly the same. So now we have a double of that. That's not a problem. We can just delete one of them later. But that's just showing that, like, this this can happen when you're merging data together. So now let's say that so this is the basic information about the school. Now we've merged on student enrollment information. So now let's say that we want to merge on demographic information. So I'm going to run this code. And so again, it just, in the time that flashed up, it's now taken the data set we had that had, like, the basic directory information, and that we had previously merged on the enrollment information. Now we've merged on demographic information about the students, like what percentage are male and female, how many students are economically disadvantaged, what percentage of students are in foster care, all of that kind of stuff. So that's, and we could, in theory, we could just keep going if we wanted to. But just to show you like a different kind of merge, the last thing that I'll put on here is, let's say we want to put in administrator experience. So that's a district level data set or file. So we only want to use district code because the using data in this case, every line represents a different district. And we want, because there are multiple schools in the same district in our master data, we're telling Stata to take, okay, for District 1, take all of that information and put it along all the schools in District 1 in the using data. So that's why it's many to 1, because, going back here, if you look at district code, we know that there are, multiple schools in the same district. So that's why it's a many, because the using data has, multiple schools in the same district. So we run this, and again, it just did all of that. And so if we wanted to like go in and actually look at the data, we wanted to scroll all the way over here to the right, that we can see these new variables that were added. So it's got stuff like, what is the average number of years of experience of administrators in the district? What is the average number of years of experience of the administrators in that district working in the district and working in their particular school? So that's the kind of stuff that's in these variables that we just merged on. So let's say that we want to do something with this data. So first off, I'm just going to drop. So this is where if you want to get rid of those, we've got some variables that are double, like, school name spelled 2 different ways. We don't need both of those, so we're going to get rid of them. There's also, just because of the way that one of our data sets looked, there's, where is it? Yeah, these random variables named P through U that don't actually have anything in them. Like you can scroll down and see there's nothing in them, so we want to get rid of all that. So we just type drop and then those variable names. And then it gets rid of all those for us. All right, so now let's say that we want to look at something like economically disadvantaged students. So that's where we would want to, so if we look at this, all of our variables are in string format, right? So if we want to try to change all of them, we just use this command here, in which star in this case just represents all the variables. And so it just goes through and does a lot of stuff, but we'll see that there are errors. So it'll say contains non-numeric characters, no replace. So let's say that we want to run something about the variable total, which is total enrollment in each school. So total enrollment, if I look in the variables tab here, it's still encoded as a string. So that means that there's something that's not a number in there. So if we want to figure out what that is, so we've got to figure out why we can't turn this into a numeric variable and change it. So tabulate, just like show me all the different values of this variable, and we see, oh look, there's one school that has n. Like, how many students are in this school? N. All right, well, we don't want that. That's a problem. It's probably a very small school or something like that. So we would got to get rid of this n. And here's how we would do that, is with this command here. So we're replacing it. Oops. So we're going to say, okay, telling Stata to go find the observation that has n for this variable total and delete it. Just make it blank. So that's what this does. Now let's try to convert that variable from a string to numeric. Oh, and it worked. So now what you can do is you could run statistics. And so we can like, oh, look, it's going to give us an average school enrollment. What's the standard deviation of school enrollment? What's the smallest and what's the largest school enrollment? All of that kind of stuff. And this is, and apologies for like, it looks clunky because I made the font really large here. So normally your version of Stata is going to look nicer. But this is a good case of where knowing your data and like spending time on the data cleaning process is really helpful. So there's a school with one student in it somewhere. That probably seems really weird. Turns out, like, I've looked at this, it's an early childhood school, because not every student enrolled in pre-K is considered a student statutorily, because they're not necessarily required to be in school. So if this is a pre-K center where there's one 6-year-old, that student it's going to show up that school has one official student in it. So that's why. But these are the kinds of things when you see there's a school with one student in it, that sounds weird. Like, you want to kind of track this down. Same thing of there's a school that has almost 5,000 students in it. That seems a little bit crazy. It turns out there's a charter network that operates multiple buildings, but as far as the state's concerned, those multiple buildings are all considered part of the same school. So that's another case where, like, this looks really wonky, but you can look at that. I mean, if you wanted, like, here's how you would, if you wanted to like kind of figure that out. Like, oh, okay. So like, oh, it's a K through 12 school. It's in Newark. It's North Star Academy. And like, you know, if you look here, there's 500 kindergartners and 500 and some first graders and stuff like that. But if you Google them, that's where you'll find out, like, oh, it's a, you know, multiple buildings. It's just that they register all of those buildings together, tell the state that they're just one school. So that's why that works that way. But anyway, so that's just an example of or where, you know, kind of doing this can help you get familiar with your data. So let's say in a different, so just to show you some of the other commands. So let's say that we want to create a variable that identifies schools with concentrated disadvantage. One way we could do that would be to say, like, to look for schools that have much higher levels or percentages of economically disadvantaged students. So the variable for that is this one right here called economically disadvantaged student, because Stata just cut off a couple characters from the end. So what we would do is basically the same thing to get ready to convert this variable from string to numeric. So there's an n in there somewhere that I could show you using the same process, but for the sake of time, I'll just kind of show you the code. So there was one school that had an n for the percentage of economically disadvantaged. So once we got rid of that, now we can convert this from string to numeric. Now let's say, well, what's the rule to say this is a school that's that has concentrated disadvantage and this is a school that doesn't? One would be if there's a policy or something that says, like, beyond this percentage, the school is considered concentrated disadvantage. It's like if you were looking at like Title I, there are rules around that, but sometimes as the analyst, you just want to, you have to kind of make up rules yourself. So what we could do is just look at the distribution and say, oh, look, like, you know, there's kind of one hump of the distribution that stops at around 40. So we would say, okay, let's say that 40 is our cutoff. So a school with less than 40% of the students is flagged as economically disadvantaged. We'll say that it's not a school with concentrated disadvantage. And if a school has more than 40% of the students labeled as economically disadvantaged, those are the schools with concentrated disadvantage. So here's how we can do that. So first off, we're going to generate a variable that's called concentrated underscore ED for economically disadvantaged. And then our rule was if it's 40 or less, if the percentage of students who are economically disadvantaged are 40 or less, we'll say that's not economically disadvantaged. And so when we make these, sometimes they're called dummy variables, or it's just 0, 1, like yes or no. 0 is if it's a no, so concentrated economic disadvantage. 0 means no, and 1 would mean yes. So you can see here if the percentage of students who are economically disadvantaged is less than or equal to 40, then we'll run the same thing, but we'll say it's a 1 if it's greater than 40. And so this just tells us that the command worked. And then if we wanted to check our work, what we can do is tabulate manipulate that. And if we wanted to look at it a different way, we could look at summaries. Actually, I'm going to change something so that this is less cluttered looking. Okay, so now the tables look nicer. But yeah, so you can see this is the not economically disadvantaged students. This is the average percentage of economically disadvantaged students, the range, and then this is for the schools that are do have concentrated disadvantage in terms of economically disadvantaged. So that just tells us that the data did what we want. If you wanted to check it sort of for yourself, that is fine. So what we would do is just go find our variable economically disadvantaged. So we can say, oh, okay, well, let's look here. So the first two should be economically disadvantaged. So our data should say 1, 1, 0, 0, and then a bunch of zeros. So we'll go over here to our variable and it says 1, 1, bunch of zeros. Okay, it did what we want. So I understand that this is a lot, kind of quick, even in a little over an hour. But at this point, so you've been kind of exposed to like these are the kinds of commands, these are the kinds of tasks, or rather these are the kinds of tasks that you would need to do to manage data, and these are the commands to do some of that in Stata. And if you have to do this, if you need to do this soon, feel free to email me, and I can email you the materials. If that would be helpful, if you need like the Stata code or something like that, I've got my email address right here. I'd be happy to email you stuff so that you can kind of play around with this and do it for yourself. The idea, if you're trying to think of like, okay, well, how is this going to work when I'm trying to work on my dissertation or some research progress or process? The way to think of it is have a sense of what you need, what the tasks are that you need to do. And so hopefully this has been helpful, like, oh, I would need to rename or recode a variable, or, oh, I need to merge some data. And then if you know what you need to do, then you just find, well, what's the command or the Stata code to do that? And then from there, it's pretty easy to look at help files and things like that to figure out how to implement it. And the last thing that I'll just kind of point out before I pause for questions is, so you'll have access to this, but like, copy and paste code. If you know someone who has figured this out, ask them for their code that you can copy and tweak to make work for you. That is totally fine. That's not considered plagiarism or anything like that, because code is code. There's not a unique way to do some of this stuff. So feel free to borrow from other people and stuff like that. And so with that, there's just a schedule here for the next couple of seminars, but I'm also happy to take questions that may have occurred to people during the course of the presentation here. So feel free to like raise your hand or just speak up or type something into the chat.
Just want to say thank you, Dr. Burns. Great presentation as usual.
Oh, thank you. Okay. Doesn't sound like there's a lot of other questions. So again, feel free to reach out and email me. If you have any questions, once these go up, like I said, those resources that I put links to near the beginning, those are really helpful. Because I think, where is it?
Yeah. Jason, it looks like Ken had a question.
Oh, yeah, go ahead.
She wrote it in the chat. She said, can you remove an observation? You don't need -99 or another filler for missing observations. It was when you changed the in the data to a blank.
Oh, okay. So you can remove an observation. That's a really good question, because those negative numbers tend to be used by whoever makes the various federal data sets, whoever processes those, and like negative, and you'll see -9, -99, -999, things like that. So this is, I'll say like, this is my preference would be to, instead of deleting the whole observation, just change those values. And the reason for that is because if you delete an observation, then you lose all of those variables for that observation. So like, let's say that you have, let's say it's a survey, and there's a -99 or something like that. If you want to use that person to describe your sample, like let's say you have they did respond and you have their information about their race, ethnicity, their gender, their education level, something like that, and you want to use that to describe the sample, you would want to probably keep that person's information. But if you just delete that whole observation, then you start to, you're just dropping your sample. If you have a data set that's really large, like thousands or something like that, losing an observation or something is probably not that big of a deal. But if you say, like, some survey platforms will do this too, like it'll say a -99 means that the respondent never saw this item or something. So if you started dropping observations because of that, you might start really whittling down your sample size. So I know it's annoying to hear responses like, it depends. But I would say, like, you can just understand the trade-offs that you're making in deleting whole observations as opposed to, just replacing values or something. Oh, okay. Sorry. Thank you for your follow-up question there. So you replaced it with a blank space. That code replaced the letter N with just a blank space. So there was just nothing there. It's the same thing as basically just deleting it. And because there's nothing in there, it's not recognized as text. So when you use the dstring command, it just, it works and converts everything to a number. And I see a few people are typing into the chat, but I just thought I'd throw back up. These are the other resources that I mentioned that if you wanted to kind of get started. And I would say if you're not a Stata user and you kind of want to get sort of an introduction to it, you go ahead and request your copy from the university. I don't know if you'll be able to get it over the summer, but so you can request the Eurostata license, and then I think a good place to start would probably be my YouTube channel. Not that I'm trying to like promote myself. I've not reached influencer status where I get paid for ads or anything. But most of them are relatively short, like 3 to 5 minutes. If you're like, oh, how do I pull data into Stata? There's like a 3-minute video on that. How do I get like an average for variables? There's a 3-minute video on that. So that might be a good way to start if you're new to Stata. Oh, okay. And thank you for your follow-up, Hind. Yeah, I'm not, SPSS may not run into, SPSS might not have problems with those negative numbers like Stata does.
Videos are a huge help, Doc.
Well, thank you. I'm glad that they're helpful. Okay, so I think it looks like there aren't any more questions coming in. So thanks everyone for coming and sticking with us. I know this was a little bit longer one. Most of them are going to be a little bit shorter, but hopefully this gives you some sort of mental bookmarks for when you need to go do this on your own, whether it's for a course or you're trying to get ready for your dissertation. So I will stop the recording here.